Welcome back. Let's get on and finish these tool holders. Right, these are the three that I made in the end. They weren't quite the disasters that I thought they were. What I did was the one that was bent, this one turned out to be okay. It's just not gone in very far, but I cannot move it. So if I can't move it, chances are it won't move when it's got a drill in it and drilling a hole. Let's hope. So that was quite accurate, so I'm not worried about that one. This one turned out to be a bit of a disaster. So what I did was, and I can't show you because it's jammed on too tightly, in the base of this chuck is a 10mm board recess. So what I did was faced off the end of the spigot, the silver bit that's pointing out, that's hanging out of this one, face it off, and reduce its diameter until it fitted snugly in that bore. So although the screw is actually the screw that it threads on is slightly bent, by the time you force it on and up against the hard shoulder, it's now running true. So that's fixed that one. That's a bit of a palaver. These are really only test pieces. If this whole concept works, I will remake them with a decent metal. These are only mild steel, and yeah, we all know mild steel is not brilliant for this sort of thing, but as a proof of concept, it should be okay. This is another old chuck I've had for several years that I use on the mill. It was turned to a spigot of 10mm, so all I did was bore out this to 10.01, I think it was, 1/10 of a mil. So it was a really nice sliding fit. Drop of that in it, dear old Loctite, and Bob's your auntie. So that runs perfectly true. This one runs really quite true. This one, the one I had to fix, is slightly off, but for a drill that's okay. What I wouldn't use it for is one of these, a spotting drill. It just wouldn't be accurate enough for a spotting drill, but the other two would be, so not overly fussed with that. If you've got a drill in it, you've got a certain amount of flex. I haven't got a drill kicking around, but yeah, if your drill's this long, then the end of it can wobble a bit, and that will take out the discrepancies in the truck, in this little Jacob's chuck. I knew what I meant. You fill in the gaps. Yeah, so that's reasonably good. It'll never be what you would call precision, but hell, it's good enough for a home workshop. I just thought I'd show you. I've made the embryo tool holders. I've finished a couple of them. There are the Jacob's chuck tool holders. They're a bit manky, but it doesn't matter. These are only prototypes. I know you're all going to complain, but they're made out of mild steel. Because I'm just trying this out as a concept. I've made a power drawbar for my little CNC mill, and this is an experiment to see whether or not it's going to work or not. That's a dovetail cutter for CNT inserts. I couldn't be bothered to make another one, so I made a collar to go around it and then heated it up and then shrunk it over. It's not great by any stretch, but it should be good enough for what I need. So there's a whole load of these, all designed for various different tools. There you go. Reasonable fit. What's that? That's a 12mm 4-flute carbide finishing mill. So next up is to take all of these holders and drill and tap grub screws in. I'll show you. Right, we're over at the mill, and that releases it. There we go. So what I need to do is this. If we can see that. Put little grub screws in. I think I'm going to put 3 in most of them, so that if there's any eccentricity I can tune it out with 3 grub screws. But this works a treat. There we go. Whoops, sorry about that. I've made a few. This is one that I made a while ago. That's a CM2 face mill that is absolutely superb. It can really rip metal out, that one. There we go. There we go. I'm not brave enough to power tap these, so I do threads, particularly small threads, by hand. Thread milling would be an interesting thing to try. That strikes me as being a really good way of buggering up a really expensive cutter. I'll have to try that one day. Really hot soapy water. Tool holes. I'm going to black that as well, which is the adapter for the headstock. All of the tool holders were given a bath in clean water, and as you can see here, I used the blow gun from the compressor to dry them off. Got myself a little conveyor system here. Tub 1 is degreaser, which finally takes off all of the remaining bits of grease and oil that left over from manufacturing. The second bath is a conditioner. Goodness knows what's in that. The third bath is the little jam jar with the blue liquid in. That's selenium something or other. That's the chemical blackening. And just on the far bottom edge of the shot you can see a bath of oil, which is dewatering oil. And they were all went through one bath after another, were dried and cleaned between each bath, and finally left for I think a week before with dewatering oil on them, before I cleaned them up and assembled them. These tool holders have been sat on the bench for a week now. They've been draining of the oil, what's it called, dewatering oil, that you put on after you've chemically blackened them. So I've left it for a week, so to give the oil a chance to sort of get into whatever porous surface the tool holders have got. And now it's a case of drying them off and putting them together and starting some measurements. So here goes. First one. They're not what you'd call very evenly coated, but I guess that doesn't matter too much. Whilst I get on with this, I'll show you some footage of a tool holder pallet that I made. I've just finished, so have a look at that while I finish cleaning these up. Off camera, I laser cut and laser engraved this pallet fascia out of polycarbonate, I think it was, 3mm thick polycarbonate. I reran the last operation to ream out effectively these holes, because it's really difficult to get the front fascia lined up with the holes underneath. So I thought it would be good to open the holes out again with the same machining op. Right, here, yep, you can see that. Here is the finished tool pallet holder. It's made out of scrap wood that I CNC routed so that all the holes were in the same place. Basically because it was easy for me to do, but the the top layer is polycarb, which again was scrap from a local plastic supplier, and I left the, when you buy plastic you get a plastic membrane over the back of it, back and the front, so you can machine it and then peel it off and leave a lovely pristine surface. Well, what I've done is just laser etched through the back and left the back protective sheet on, and then just stuck it to my wooden blanks. I think it looks quite effective, to be honest, and it should be relatively easy to keep clean, and also I shouldn't get confused with what tool is what, so they all seem to fit. Here's a tip for you though: when you do this, if you do this, make sure you make your hole big enough. I made my holes exactly the same diameter as this, so I had to sand every single one. That didn't take more than an hour and a half. Anyway, there you go. Here I am assembling the tool holders, putting the tools in, adding the grub screws, tightening them up, and getting ready to test them. That is a simple little dovetail cutter using CNC inserts, and I made that because this is the quick change tool post tool holder for the lathe, and that's a 60-degree dovetail. So you can see clearly this cutter was designed specifically to cut these out. These things are quite, they're made in China, and they're quite expensive to buy in the UK, so I've got myself a good bit of bar stock. Not quite this shape, but that's going to be my, my first project to see if I can make some of these using the CNC mill. With these tool holders that I've made. So there we go. So I think the moral is, don't be frightened to actually have a go at making your own tool holders. You don't need to buy them. If you've got the time and a bit of ingenuity, it's not that difficult. Here's another one I made. This is quite old now. It's a 3-flute CNT end mill, or what do you call it, face mill, and this is an absolute brute. There's again, it was I made it on the CNC, and because I've got a machine with a 4th axis, so you can rotate. Yeah, let me show you. You can cut a pocket out, rotate it, cut another pocket out, and then continue round, and they will always be concentric, so they'll always the tool position should be the same, so the tool height should be the same in each one. But as it's only a roughing tool, it doesn't matter if you're out by even a 1/4 millimetre. It wouldn't matter. You just leave a rough finish, which you then go over with another end mill to flatten it off. So it's, you know, for hobby use, it's not the end of the world if it's not right. Right then, let's try tool number 1, which is a 2.5mm high-speed steel FC3 3-flute flat end mill. But let's just see what the run-out's like on the holder to start with. There we go. Turn the spindle on. I'll bring you in closer. There we go. That, I reckon, is 0.02 of a millimetre. That's the highest one, highest cutting tip. That's the lowest one, I think. Yep. So we are looking at doing that. Allen key up a little tighter. That's pretty close. Let's move that to 0 so we can... Oh wait. Right. Ooh. Let's come back a bit. Okay, so that's the tip of that one. That's the tip of the next one. And that's the tip of the third one. I reckon that's pretty close, personally. I think I'd buy that. Hey, that's looking alright. Pleased with that. Now I've got to go through all of the others and line the rest of them up, so I'll do that off camera because it is a bit dull. I think the maximum run out was 0.02 of a millimetre. I think that's good enough for a home workshop. Thanks for watching, hope you enjoyed. Give us a thumbs up if you really did enjoy it, and consider subscribing. See you next time, take care, ta-da!